Hello viewers, welcome back. Today we'll be moving straight to episode 2 of our series on experimental. eh, Welcome back. Today we'll be moving to the episode 2 of our series on elementary statistics. Today we're going to be talking about data visualization, a journey through graphical summaries. My name is Ajadi Noruddin. Now, the first thing we'll be talking about is the qualitative data. And here, I'll be talking about the frequency distribution. What is the purpose of the frequency distribution? The main purpose is to organize data into categories and count occurrences. For example, we talk about the gender. For the gender, we have the male and we have the female. These are the categories. So, how to organize the data into these categories? This is the major purpose of the frequency distribution. And then when we talk about the frequency distribution, this display categories with their frequencies. For example, how many female students do we have in the class? How many male students do we have in the class? Okay, so these are categories. And secondly, we talk about the relative frequency. What is the difference between frequency and relative frequency? For relative frequency, we're talking about proportion of total data values in each category. I'm going to show you how this works out in the next slide. And there are some key notes we need to pay attention to. Is that for frequency, the total frequency must be the same with the sample size we have. If the sample size is 36, the sum of the frequencies must be the same thing as 36. That is about the frequency. And about the relative frequency, the sum of our relative frequency must be equals to 1 or 100%. So when you sum it up and you are not getting 1 or 100, then there's a mistake somewhere. Now we have this example. This example is about ice cream sales by flavor in a month. So we have 4 types of flavors. We have the vanilla. I know a lot of people love vanilla. We have the chocolate, we have the strawberry, and we have the mint chocolate. So these are the sales for each of the flavor. Our objective is to calculate the relative frequency. Now, if you look at this example, the sales here, this represents the frequency for each of the categories. So the sale represents the frequency. And like what I said, for frequency, the sum must be the same thing as the sample value. So when you find the sum of these, 120 plus 85 plus 50 plus 45, this is going to give us 300. This is the sum of the frequency. Then how do we calculate the relative frequency? To calculate the relative frequency, you need the frequency for each of the category divided by the sample size. Now, to get the relative frequency for vanilla, we have the frequency, which is what? 120 divided by 300. And this is going to give us what? 0.4. And in percentage, you can say that this is the same thing as 40%. Now, doing the same thing for chocolate, we have 85 as the frequency for the category divided by the total of 300. This gives 0.28, and this is equivalent to 28%. Doing the same thing for strawberry, we have this to be 50 divided by 300 equal 0.17, which is the same thing as 17%. And for the last, which is the mint chocolate, we have 45 divided by 300 equal 0.15, which is the same thing as 15%. And the rule for relative frequency is that the sum of the frequencies must be equals to 1. If you add this up, or what? If you add up the percentage, this should be the same thing as 100%. So this is how to calculate relative frequency. Number 2, we have surveys on hours spent studying in a week by 20 students. So we have the data value given to us, and our objective is to construct the relative frequency distribution. Okay, this is our objective. Now, to do this, we have the study hours given. We need a frequency. Unlike the previous example, the frequency has been given to us. But in this example, we don't have the frequency. Now, to get the frequency, we have the study hour of 5. Now, let's strike out everywhere we see 5. Here we can see 5. This is 1. This is 2. You will have to be very careful so that you don't miss out on a value. This is 3. Now, looking at this, 5 comes up 3 times. Now, let's move to 6. How many times do we have 6? We have 1, we have 2, we have 3, and we have 4. So this shows that the frequency for 6 is 4. What about 7? 7 we have 1, 7 we have 2, and here we have 3. And let's move to 8. So we have 1, and we have 2, and we have 3. The purpose of striking out is for you to be able to identify the one already counted. And now we move to 9. How many 9s do we have? We have 1, we have 2. So 9 comes up 2 times. What about 10? For 10, we have 1, we have 2, we have 3. 10 comes up 3 times. What about 11? 11 just only once. What about 12? 12 just only once. So this is the total of what we have. If you add this up, you should get 20. Then how do we get the relative frequency? Using the same method, the same approach. Here we have 3 divided by 20. This should give 0.15. Here we have 4 divided by 20. Here we have 0.20. Here we have 3 divided by 20, 0.15. 3 divided by 20, 0.15. 2 divided by 20, 0.10. 3 divided by 20, 0.15. 1 divided by 20, 0.05, and 1 divided by 20 gives 0.05. If you add up this should be equivalent to 1. So this is how to solve the relative frequency. Now we move straight to visualizing the qualitative data. How do we visualize our qualitative data? First thing, we talk about the bar graphs, and also we talk about the pie chart and the Pareto. Under the bar graph, it can be classified as bar charts and histogram. And also under the bar chart, we have single bar chart, multiple bar chart. Okay, but everything is going to be under the bar graphs. In bar graphs, a bar graph looks like this. Okay, we use bars of equal width to display frequency or relative frequency, and this can be vertical or horizontal. So this is what a bar graph looks like. And secondly, we have a pie chart. It's in form of a pie. It's in form of a pizza. Let's put it that way. Now, this represents relative frequency as sectors of a circle, useful for showing part of whole. So this is what it looks like. Okay, we have something like this. And lastly, we have a Pareto. So these categories ordered by decreasing frequency highlight the most significant categories. That is one thing about Pareto. And here we talk about quantitative data. In the previous example, we've talked about the qualitative data. It's in form of a ungrouped data. And here, I want to talk about a quantitative, which is going to be in form of a grouped data. Now, there are some steps we need to follow. For you to construct the frequency distribution, the first thing we have to do is to determine the number of classes. In this example, you can have wide range of values like 1 to 100. It's going to be difficult to list out 1 to 100 and start finding the frequencies. So what we do here is to use classes. Okay, this is the difference between this method and the previous one we did, because in the previous example we did, let me just go back. If you look at the study hours, we have from 5 to 12, which is very easy for me to get the frequencies. But in situation whereby we have large values, it's going to be a little bit difficult. So we use classes. Now, for classes, for example, let's assume we have 1 to 5, 6 to 10, 11 to 15, and 16 to 20. These are classes. In this case, we have the number of classes here. We have it to be 4 classes. 1, 2, 3, 4. Now, you have to determine the number of classes you want to use. Secondly, you calculate the class width. How do you calculate the class width? You check. There are some methods used in calculating class width, but the easiest method is 1, 2, 3, 4, 5. 1 to 5, 6 to 10. The difference between this, the width is 5, 5. 6 to 10, 11 to 15, 16 to 20, they are 5 values. So here, the class width are the 1 to 5, the 6 to 10, the 11 to 15. So what is the class width? Here we have it to be what? 5. If you look at the width, it is 5. Okay. Now, we set the lower limit. These are the lower limits, while these are the upper limits. Okay, 1 is the lower limit, 5 is the upper limit. And lastly, we tally the frequencies and calculate the relative frequency. But there are some key notes. Every value must fit into one class. You have to take note of that. There must not be any value without a class. Secondly, class should have consistent width. In this example, I'm using width of 5. And lastly, the total frequencies and the relative frequencies must sum correctly. This is very important. Now, we have this example. Now, in this example, we have the random sample of work durations in minutes by gym members. So we have 40, 45. These are the values. Now we want to use 6 classes to construct the frequency distribution, and the classes has been given to us here. Now, how do we get the frequencies? To get the frequency for the first class, 40 to 45. So you need the frequency for all the values that fall within the range. Let's go from 40 to 45. Here we have 40, which is 1, 2, 3, 4, 5, 6, and 7. So the frequency is 7. For the second one, we have the next one we have from 46 to 51. Now let's count from 46 to 51. Here we have from 46 to 51. We have 1, we have 2, here we have 3, here we have 4, 5, so we have 5. From 52 to 57. From 52 to 57. Here we have 1, 2, 3, 4, 5, 6. So here we have 6. 58 to 63. We have 1, 2, 3, 4, 5. 64 to 69. 64 to 69. 1, 2, 3. And 70 to 75, we have 1, 2, 3, 4. So for the relative frequency, using the same method, if you find the sum of these, the sum should be 30. And for the relative frequency, we have 7 over 30. This gives 0.233. 5 over 30, which is 0.167. 6 over 30, 0.200. 5 over 30, 0.167. 3 over 30, 0.100. 4 over 30, 0.133. So this is what we have as the relative frequency. If you sum this up, it's going to be 1. So this is for grouped data. And here we talk about the histogram visualizing the quantitative data. Just the same approach. The first thing we have to do is to get the data collection. Your data can be on anything. It can be on work, duration, or anything. Secondly, you create the frequency distribution. This is done by organizing your data into classes. And thirdly, construct the histogram. And lastly, analyze the shape. How do we analyze the shape? After histogram have been constructed, how do you analyze the shape? In this previous example here, you can use the frequency or the relative frequency to construct the histogram. On this horizontal side, you can have the frequency, and also you can have the relative frequency. And here you can have your variable, your data values on the horizontal side. So this can be plotted using a concise and the same scale. Now, looking at your histogram, now you can use your Excel or anything, whatever, to draw your histogram. In fact, you can use your TI-84 or TI-83, which we are going to be using in subsequent classes to draw your histogram. Let's talk about the shape of the histogram. If your histogram is bell shape like this, bell shape, this is called symmetric. This is called symmetric. Why? Because both sides are mirror images, common in normal distribution. And I want you to pay attention to this very well. For a bell shape, this follows normal distribution. We're going to be talking about this in subsequent episode. This follows a normal distribution. And if you look at the second shape, this is called skewed to the left. Why? The easiest way you can get this is you can see it coming down. So the tail extends to the left, also called negatively skewed. So the scale extends to the left, just like in form of decreasing. This is called skewed to the left. And if you look at the last one, This is to the right. This is to the right. This is to the right. This is called skewed to the right. Or even you can, yeah, this is skewed to the right. From this down here. Or you can even say this is going up and this is coming down. Either way. But if the tail extends to the right, we say skew to the right. If the tail extends to the left, skew to the left. To the right, skew to the right. This is the easiest way for you to understand the two. So any histogram you've seen, it's easy for you to say, oh, what does this mean? And also, when it is symmetric, it means the mean is the same thing as the median. So we have it skewed to the left and skewed to the right. And the next thing we have here is stem and leaf plots. For the stem and leaf plot, this is another way to visualize your data, and it's very easy and straightforward. How do we do the stem and leaf plots? Number one, we separate the data into stems and leaves. The stem and leaf, just like you have a tree. We have the stem, we have the branch, we have the root, we have the leaves. So here we call it the stem and the leaf. Secondly, we order the leaves. It can be in ascending or descending order, but I prefer ascending. Number three, you include a key. Now, let's use this example below. Just on the workout durations in minute by 30 gym members, we want to use this to construct the stem and leaf plots. Now, this is the key. If you have 40, your 4 is going to be the stem, and the 0 is going to be the what? The leaf. So the units will always be the leaf. Now, let's look at this. Here we have 4. So for 4, we have 40, we have 45, here we have 40, here we have 45, and here, let's look at where we have 4, 40, and here we have 45. So what is going to be the leaf? Now, the leaf here is going to be, look at this, we have 40, we have 0, and here we have another 40, we have another we have 0, yeah, and here we have, you don't need to repeat, so here we have 0, 0, 0, 5, 5, 5. So this means we have 40 3 times and we have 45 4 times. Okay. And then if you look at 50, here we have 50 5 times. 1, 2, 3, 4, 5. Also we have 55 6 times. 1, 2, 3, 4, 5, 6. Coming to 60, we have 65 times. You can check it because of time. 1, 2, 3, 4, 5, and 65 3 times. 1, 2, 3. And for 70, we have 73 times. And we have 75 1 time. So this is how the stem and leaf plot works. And also we can have the back-to-back stem and leaf plot. For back-to-back stem and leaf plot, this is just following the same method. You need to identify the two data sets. You create separate stems. You add a leaf to both sides. You include clear labels and you analyze. So most times it always look like this. Here you have the stem. You have the leaf, and on this side too you have the leaf. So they can have the same stem, but the leaf can be different. So this is how it works. And lastly, you have to avoid the misleading graphs. Yes. The first thing we have to note is that when you are drawing a graph, the proper labeling is very important. You ensure the horizontal and the vertical axes are clearly labeled and scaled appropriately. Most times, this can be the frequency, or in another case, it can be the relative frequency. Okay, and this can be your data values. It can be A in classification B, C, D, E. So you have to label it accordingly. And there's something we call area principle. That is, if you look, the proportion in graphs should accurately reflect the data they represent. When the data value is very small, then this shows that this is smaller than this. This can be 15 and this can be 20. So it should reflect what the data truly represent. And also we have the consistent scaling. So there should not be distortion in the data set, and the contextual information needs to be provided. At the end of this class, I believe you've been able to learn how to choose appropriate graphs, okay, for the qualitative and the quantitative, and the accurate construction. The most important part of this class is how to interpret graph when we have it skewed to the left, skewed to the right, and symmetric. This is very important. Thank you very much for watching. See you next time. Bye.